is celebrated for giving us the special theory of relativity, the fact that nothing goes faster than light, time is the fourth dimension. But he didn't come up with the equations. That was the interpretation, the narrative of the equations. And it's the same with any other theory in physics. With quantum mechanics, it's different. We have the equations of quantum mechanics, but we can't agree on what that equation means. Schrödinger's equation being the most famous one. We can crank the handle and produce numbers from the equation, but the narrative, the story, the explanation is still something that we're arguing about. And that bugs me. By the end of the 19th century, it was already known that we needed some new physics to explain mysterious phenomena, X-rays, like radioactivity, that energy seemed to be coming out of nowhere, to understand the behavior or the structure of the atom. And so when quantum mechanics came along, it wasn't because physicists were sitting, scratching their heads thinking, there must be some deeper understanding of the nature of reality. I know, let's come up with quantum mechanics. It was forced on physicists because of experimental results that were inexplicable. It's a fuzzy, probabilistic world. Things are never behaving in one way for certain. Atoms can have two energies at the same time. Electrons can be in two places at the same time. Particles aren't discrete little lumps. They can sometimes behave like spread out waves of probability. It's really down at a level far beyond anything that we can visualize or imagine. If we think about everyday objects, a tennis ball, for example, subject to the laws of Newtonian mechanics, you drop down orders of magnitude, down to a millimeter, down to a micrometer, down to the scale of individual cells or bacteria. Ultimately, when you get down to something like a billionth of a meter, then you start to encounter the fuzziness of the quantum world. The founding fathers of quantum mechanics in the 1920s, people like the Danish physicist Niels Bohr, Werner Heisenberg, Wolfgang Pauli, and they realized they could make predictions for the results of measurements. But you only make the connection with the real world if you look. So that's how they got away with not needing a narrative, the shut up and calculate interpretation. More correctly, it's known as the Copenhagen narrative. But now, many physicists, including myself, argue that it's not a narrative at all. It's a bury your head in the sand approach. Einstein was very unhappy about this, by the way. He said, no, look, the job of physics is to know and understand how the world is, not just to make predictions about the results of experiments. That sort of operationalist view, well, fine, that's useful, but that doesn't give us real understanding. That's why we still need a narrative. The knowledge of quantum mechanics, together with Einstein's theories of relativity, really gave us the modern world. We wouldn't have developed understanding of materials and how they conduct electricity, so we wouldn't have understood semiconductors, we wouldn't have developed silicon chips, therefore we wouldn't have computers. I wouldn't be talking here in this medium today were it not for our quantum understanding. But there are aspects of the quantum world that are more mysterious. Quantum entanglement, for example, the idea that, let's say, two electrons that are separated in space can nevertheless somehow behave in a coordinated way. There are speculative ideas about whether space itself is connected together via quantum entanglement. We don't all need to be experts in quantum mechanics. Not even the smartest quantum physicist knows how stuff goes on inside their smartphone. But we are going to be developing ideas like quantum cryptography, quantum computing, quantum sensors. These are ideas and technologies that are going to affect us in our daily lives. So we do need to have enough of an appreciation of the science simply to know what to trust, who to trust. As we peel back layers of the onion about the nature of reality, we find deeper mysteries inside. But it's also true that we are learning more. We are becoming more enlightened. We know a lot about how the world works now, but that doesn't mean we have reached the end of the road. No, I think there's going to be more weirdness coming down the line, and that's great. I look forward to it.
Ernst, my good man.
Ah, 2 tins of the usual, Professor?
Indeed. And I would like you to meet my good friend and thorn in my scientific side, Dr. Niels Bohr.
Hello. An honor to meet you, sir.
Ernst, are you familiar with Heisenberg's uncertainty principle?
I can't say that I am, Professor.
Well, it states that the more accurately we measure the velocity of a particle, the less accurately we can measure its position in space.
So you know exactly how fast the thing is going?
Yes, but if we do, we cannot also know where that thing is. Does that sound logical to you?
No, sir.
Of course not. And according to my esteemed colleague, the particle does not exist at all until we observe it.
That makes absolutely no sense to me.
Exactly. Thank you, Ernst.
Shall we stop by your butcher's as well? Perhaps he has an opinion on the matter.
Ha ha ha. Very amusing.
Albert, the uncertainty principle works. It functions. And it allows us to make use of the quantum world.
The goal of scientific pursuit should not be merely to make use of the world around us. It should be to understand it, fundamentally. No matter what use it might have. Albert, look out!
Just watch where you're going, please.
Why should I? Why should either of us? According to you, if that automobile was a particle, but we didn't see it, it wouldn't have been there at all. We would be perfectly safe.
Automobiles aren't subatomic particles, Albert.
Niels, it defies common sense that the rules which govern those things we can see do not apply to those we cannot. I will not turn off my brain simply because you've decided the matter is settled.
Well, if you don't start using your brain to observe what's right in front of you, you're going to get yourself killed.